What's up, brilliant minds? Welcome to Mind Loom Labs, the channel where we don't just learn, we grow our minds. If this is your first time here, hit that subscribe button because we're all about making complex topics simple, exciting, and actually fun. In today's lesson, we're going to explore data conversion, registers in a computer, and how data moves around inside your system. Let's dive in. First up, what is data conversion? It's simply the process of changing computer data from one format to another. Think about it. Every computer device uses different ways to store and understand data. For example, your hardware might read data in binary, which is just ones and zeros, while software may need that same data in text or image format. So, data conversion acts like a translator, making sure that information is understandable and usable wherever it's needed in your computer. Now let's talk about registers. Inside your computer's brain, the CPU, there are small, super-fast storage spaces called registers. These are used to hold data or instructions temporarily while the CPU is actively working on them. Imagine them as tiny notepads the CPU uses to jot down notes and keep track of what it's doing right now. There are several types of registers, each with a specific job. The memory address register, or MER, holds the memory address of the data or instruction the CPU needs next. The program counter, or PC, is like a bookmark, keeping track of the next instruction to execute. The memory data register, or MDR, temporarily stores data that's coming from or going to memory. The accumulator, or AC, stores the results of calculations done by the CPU. The index register, or IR, can modify addresses for instructions. And finally, the data register, or DR, is used to temporarily store data moving to or from other devices connected to your computer. So, how are registers different from main memory or RAM? Well, registers are inside the CPU, they're incredibly fast, and they only hold data that's being used right at this moment. Main memory, on the other hand, is outside the CPU and stores data and programs that aren't currently being processed. You can think of registers as the CPU's short-term memory and RAM as its long-term memory. All this work happens in a cycle called the instruction cycle. It has three main steps: fetch, decode, and execute. First, the CPU fetches program instructions and data from main memory. Next, it decodes or understands what the instruction means. Finally, it executes the instruction, performing calculations or moving data as needed. This cycle repeats millions of times per second. And how does all this data move so quickly? Through something called a bus. A bus is a pathway that transfers data between computer components. The speed of data transfer depends on two things: bus speed, which is how fast bits travel, and bus width, which is how many bits can move at the same time. A wider bus is like a multi-lane highway. It can carry a lot more data at once, making everything faster. There are different types of buses, like the address bus that specifies where data should go, and the control bus that sends signals from the CPU to other devices. So, to recap, today we learned that data conversion changes data into usable formats. Registers are tiny, fast storage spaces in the CPU that hold data temporarily. The fetch-decode-execute cycle is how the CPU processes instructions, and the bus system allows data to move efficiently inside the computer. That's it for this lesson. I hope this helps you understand a bit more about how computers really work. Thanks for watching, and don't forget to like and subscribe for more tech lessons.